If you look just 45 kilometers east of Cairo, you'll see the beginnings of a city rising from the sands. Egypt's new $58 billion administrative capital is no ordinary project. It's a sprawling urban masterpiece designed to transform the future of the country. The city plans to host 6.5 million residents and features a skyscraper that's set to be the tallest in Africa. Built to house all government offices, it aims to be the nerve center of the nation. They're even constructing an iconic tower using 18,000 tons of steel, enough to make the Iron Man jealous. Why is Egypt pouring billions into creating this brand new desert city? Egypt, a land of ancient wonders, is at a crossroads. Known for its towering pyramids and the majestic Nile, it faces a modern-day challenge: an ever-growing population crammed into the bustling city of Cairo, constructing a brand new city from scratch in the heart of the desert. This ambitious project, named the new administrative capital, aims to alleviate Cairo's congestion and overpopulation. Imagine a sprawling metropolis emerging from the barren sands, designed to house millions and serve as the new hub of Egyptian government and culture. The new city is envisioned to be a beacon of modernity, featuring cutting-edge infrastructure and state-of-the-art facilities. Set in motion in 2015, the new administrative capital project was initially budgeted at $45 billion. However, like many grand plans, it has encountered delays and ballooning costs, now projected at over $58 billion. Despite these hurdles, the vision remains clear: a city that symbolizes Egypt's future. Central to this vision is the government district, where towering ministries and parliamentary buildings will dominate the skyline. Adjacent to this is an opulent presidential palace, surrounded by expansive gardens and lavish grounds. These areas are designed not just for function, but to impress and inspire. The city also features monumental cultural landmarks, such as the Egyptian Grand Mosque, the largest in Africa, and the Nativity of Christ Cathedral, the largest church in the Middle East. These structures stand as symbols of unity and coexistence, reflecting Egypt's diverse heritage. How are they transforming these ambitious plans into reality in the heart of the desert? One of the cornerstones of this project is the Central Business District, highlighted by the iconic tower, which will be Africa's tallest building at 400 meters. Its design is inspired by the obelisk of Luxor, symbolizing strength and stability. The main structure adopts an outer steel frame and a reinforced concrete core tube. The tower has utilized a total of 18,000 tons of steel, with the maximum weight of a single steel structure reaching 28 tons. Building such a colossal structure in the desert required innovative techniques. For instance, the foundation is a composite steel structure grounded on a reinforced concrete raft. This raft spans 3,710 square meters and is 5 meters thick, creating a volume of approximately 18,500 cubic meters. The sheer weight of the steel reinforcement alone is around 4,600 tons, emphasizing the engineering prowess behind this endeavor. The casting of the foundation was a feat in itself. Engineers decided to cast the entire raft in one stage, without any construction joints, to ensure uniform strength and stability. This required meticulous planning and coordination, with 7 batch plants and 10 production lines supplying concrete simultaneously. The concrete mixture was specially designed to have a low heat of hydration, using cement-type CEM2 and adding silica fume to maintain a flowable consistency and extend setting time. The construction of the iconic tower set a new record for the fastest construction speed, with 4 days per floor for the main structure and 3 days per floor for the steel structure. The steel structure construction involved a bottom-up concrete pumping method, a significant departure from the traditional top-to-bottom pouring method. This significant innovative approach allowed for the efficient and speedy casting of 16 columns within 33 hours. Another remarkable feature of the new capital is the Green River Park, which runs through the city's center, mimicking the Nile River. This 6-mile-long green space will be double the size of Central Park in New York City and is designed to provide a lush, serene environment amid the bustling city. Engineers have integrated sustainable water management systems to maintain the greenery, including advanced irrigation techniques that maximize water efficiency in the arid climate. The Presidential Palace complex is another engineering marvel. Spanning over 2 square kilometers, this area includes the palace itself, which covers 50,000 square meters. Engineers face the challenge of creating a space that balances security with grandeur. The palace features advanced security systems while incorporating elements of traditional Islamic architecture, complete with opulent throne halls and extensive gardens. Transport within the new capital is facilitated by a state-of-the-art monorail system connecting it to Cairo. This system aims to alleviate traffic congestion and provide a rapid, efficient mode of transportation for residents and officials. Engineers employed the latest technology in rail transport to ensure safety, speed, and reliability. The monorail tracks are elevated, minimizing disruption to the city's landscape and allowing for seamless travel across different districts. Sustainability is a key focus in the construction of this new city. Engineers have incorporated renewable energy sources, such as solar panels and wind turbines, to power the city. Buildings are designed with energy-efficient materials, such as autoclaved aerated concrete or AAC blocks, which provide excellent thermal insulation and reduce energy consumption for heating and cooling. AAC blocks are not only lightweight and easy to install, but they also have a lower environmental impact compared to traditional red bricks. The use of AAC blocks is particularly notable in the construction of residential buildings. These blocks help reduce the overall weight of the structures, leading to savings in steel and concrete usage. For instance, using AAC blocks in a typical apartment building can result in a 43% reduction in the amount of cement used in mortar, significantly lowering the environmental impact. Fire resistance is another advantage of AAC blocks. They can withstand high temperatures for extended periods without compromising structural integrity. This makes them an ideal choice for ensuring the safety of residents in the new capital. The construction of the new capital also includes the development of the world's largest Islamic cultural center, the Egyptian Grand Mosque. Covering 250,000 square meters, this mosque can accommodate over 130,000 worshippers, making it the largest mosque in Africa. The mosque's design draws from medieval Mamluk architecture, featuring intricate carvings and expansive courtyards. Engineers had to ensure that the foundation could support the immense weight and that the roof could span large open spaces without columns obstructing the view. Adjacent to the mosque is the Nativity of Christ Cathedral, the largest church in the Middle East. This massive structure is designed to foster unity between Egypt's Muslim and Christian communities. Engineers used advanced acoustic techniques to enhance the sound quality within the vast interior, ensuring that services can be clearly heard by all attendees. Throughout the city, sustainability is prioritized. Buildings incorporate advanced HVAC systems that reduce energy consumption and improve indoor air quality. Water recycling systems and green building practices are employed to minimize the environmental impact. The aim is to create a city that's not only visually stunning, but also environmentally responsible. While the construction of Egypt's new administrative capital has been a monumental feat of engineering and innovation, it has not been without its share of challenges and problems. One of the most significant issues has been the project's ballooning costs. In terms of technical challenges, building the iconic tower, the tallest building in Africa, has required overcoming numerous engineering hurdles, ensuring the stability of the tower's foundation in the sandy desert soil, managing the heat generated during concrete curing, and achieving the rapid construction speeds necessary to stay on schedule, ensuring the stability of the tower's foundation in the sandy desert soil, have all tested the limits of current engineering practices. Logistics have also posed a considerable challenge. Constructing a city from scratch in the desert requires extensive infrastructure development. This includes not only the buildings themselves, but also roads, utilities, and public transport systems. Public opinion has been divided on the new capital project. While some view it as a symbol of progress and a necessary step to alleviate congestion in Cairo, others criticize it as an extravagant use of resources that could be better spent on addressing more immediate social and economic issues within the country. Despite these challenges, the project has continued to make remarkable progress. The construction of the new capital represents a bold vision for Egypt's future, aiming to create a modern, efficient, and sustainable city that can serve as a model for urban development in the region.